It's not working. We are speed and professionals in aeromatic. Welcome back, everybody. So today we're actually going to be doing some cleaning on our rotating assembly and some rotor housing. So one of the things that I'm going to be doing is my 1987 Turbo 2 rotors that I have. These came out of a great running engine, little carbon buildup, all that kind of jazz. We're going to clean these up. So lots of carbon buildup. In the on the faces, as well as we have it, you know, in the side seal area on the faces or the sides of the rotor, and then our rotor housings as well. We want to get cleaned up. So these rotor housings are like immaculate shape, as you can see there. Not a whole lot of wear through, but they need some cleaning up. They've been used. But these are great candidates to be able to use for a semi-peripheral port engine is what we're going to be having in the new drag car. And normally I use REW rotors, but the 87 to 88 rotors, these are a lot thicker, so less prone to denting and potentially can handle more boost, as well as are a little bit heavier. So that heavier rotating assembly will give us a little bit more torque. That torque is really going to be able to help us out running drag radials, to be able to have a little bit more torque out of the motor. Rotaries really aren't known for it, but with 87 turbo rotors being a little bit heavier, that mass is going to be able to give us a little bit more oomph off the line, which those 60 foots, that's where it's all going to be about. So hopefully it's going to pay off for us in the long run. But today, we'll take a look at what these engine parts come out of the car looking like on a, you know, motor that you might find out of a junkyard or a JDM block, and not a brand new by all means, but it's new to me, rotating assembly as well as rotor housing. So let's get to it. So as you can see, a few things that really piqued my interest, especially with these rotor housings, is there's absolutely no edge wear flaking. That's really, really important to me with getting used rotor housings, is that edge wear and just that inside surface of the chrome. So as you can see on this one, still the exact same thing. I mean, no real edge wear flaking that you can see on there. Now, we can see a little bit of some distortion on the exhaust port itself. So we're going to have to really clean this up, see what this side looks like. Basically with rotor housings, from my experience that I've seen, these actually shrink. The aluminum, as it heat cycles, gets really hot. These will shrink, and then you'll get blow by through here on your water jackets, which will actually leak coolant into the engine. Same as on this one. Now, other than that, these housings look awesome. And then we're going to do what's called the semi-peripheral. So this is going to actually get bored through, and there'll be a hole inside of here. So you'll have a hole through here. And that's generally anywhere between a 30 to 38 millimeter hole that comes through here, which is going to then take intake air, just like an extra added intake port, and that'll be on both rotor housings. So that's why I really want to be able to use these housings, because of the shape that they're in. They're in really nice shape. I will not resurface these. We'll leave these as is. And then just kind of clean them up and sandblast the inside edges, the outside, get them looking brand new again from the exterior side. Make sure that there's no real deep corrosion on the water jacket port, so I don't have any issues with bypassing any kind of coolant or anything like that. And then the rotors, you can see these guys have a lot of carbon. So this is carbon buildup. So on your rotors, when you get this massive amount on here, this isn't good. This can actually lead to pre-detonation, which will make the either corner seals crack, or you'll have apex seal failures, because with all of this carbon buildup, that creates a lot of heat. This will actually be like a hot amber, and that will actually ignite just like a spark plug will on your the face of the rotor, which will mess with the timing of the engine, where this carbon buildup can be just as hot as a spark plug igniting. And with that heat temperature pre-igniting your fuel, that's where you can have a lot of issues. So keeping a nice clean burning rotary and still yet being well lubricated, it's a challenge in itself, but by doing that, we'll absolutely make it so that the life of the engine will last a lot longer. We can see on the areas here, didn't really have a whole lot of blow-by. You would see this dark area here kind of bleeding into the face where your oil ring and everything is. If it had a lot of blow-by through here, this motor really doesn't look like it had a whole lot of blow-by. By looking at this side, the side clearances of the actual rotor itself. The bearings look good. Obviously, those will be replaced, but no major areas of concern on either of these rotors. They both look really nice. They just need some good cleaning and some wire wheeling on the faces. We will take a flat block to the outer sides here, just like we'll take a flat block to the surfaces of the rotor housing. And then we'll see what these guys look like after we're done. So let's get to some work. I'm probably not going to show you guys all of the work involved. If you've seen somebody working on a rotary, it could be in time lapse. It's still going to be boring. So let's just look at the aftermath in 3, 2, 1, go. Wow. I cannot believe how fast that goes. But I will say, yes, we are missing a rotor housing because one is still yet to be cleaned. But look at how these rotors turned out. I mean, yes, they got some scuff marks, whatever, but everything's marginal. I mean, these are ready to get sent out to balancing, blueprinting, clearancing, all that good stuff. The rotor housings turned out absolutely mint. We'll clean these guys up. These actually are going to get cut right through here anyways, so I'm not too concerned, like I said. But all in all, this is a great motor to start with as our baseline for the stick shift car. So really excited to see how these rotors do, as well as doing semi-peripheral port. We'll get more into that as to what this is really going to do for our motor once we have the billet plates for the front and rear end, and we'll get more in depth into there. But as you can see, we are ready to send these guys off. It was an amazing clean. This other housing is still in the cleaner right now. I swear to God, all this dust in the cast iron, all the... Give me a moment. I swear to God. I wear a dust mask too. It was an N95. Oh, it's not working. Honestly, I cannot even believe how dirty that I am after running through the sandblaster and just cleaning up the rotors and rotor housings. It's a dirty job, I will say, and it's a thankless job. So now that we have our rotating assembly basically ready to send off, so that Leo Tavares over at Balance Wiz can take care of that portion of it, we'll send hopefully our rotor housings out to Rotary Science. We'll get a hold of Michael over there. But those are kind of like the game plays that we have going on right now. So let's get to it and continue on. So one thing that I'd like to kind of just share with this video is also porting. So I couldn't just clean up the housings. I had to go the extra little step here and go through and do my normal port job for the exhaust port for a turbo. Now with it being a semi-peripheral, I open this up just a little bit larger because we are going to be flowing a little bit more air than just my normal Bridgeport motor that I normally do. But just to kind of take a look, so with rotaries, it's a misconception of how big that you port the engine. So porting a rotary engine is like putting a big cam in a piston engine. The big difference is when you put a cam in a piston engine, you can take that cam back out and then it's back to normal. When you port a rotary engine, you're changing the intake and exhaust timing just like you are when you put a larger cam in to change the duration of the intake and exhaust valves. With a rotary, once you do this, you can't undo it. So I try to be very precise and know that if I ever want to, I can always go bigger. I've never had the need to, but being able to have these ports open and close at the same time, if you can imagine a apex seal from the rotor, basically swiping across this portion to open the exhaust valve and then swiping across again to close it. You want these to be basically an open and shut door. You don't want to, in my opinion, and this is my opinion, you don't want this ovaled out and ovaled at the top, just because you're basically creating gaps in where air is trying to squeeze its way out and you're letting it squeeze air out, the exhaust pressure. Whereas when you shut it, it's like shutting a door and it stops that stroke. So you're not losing any power, if that makes sense. So with my exhaust porting, this is what I would normally do. I'm not, trying to hide any secrets or anything like that. I do like to round the finish on the edges. So you can see here, there's no sharp edges around the actual port itself so that the apex seal is not getting chatter or wear just from this side portion or the top when it's closing this or when it's opening this. It's got nice rounded beveled surfaces. So that's just a little bit of the porting that I do. But yeah, the rotor housings turned out great. And that's where we're going to end it on this video, guys. Really appreciate you guys for hanging out in the garage with me. Hopefully you enjoyed my struggles and allergies dealing with all the sandblasting dust and the carbon buildup from cleaning the rotors. What a dilemma. But yeah, it was a great time. Please remember, like, subscribe, share with your friends. Give me a comment. Really enjoy going through those and the support you guys are giving this page. So hopefully we won't disappoint. We'll continue on. We'll catch you guys in the next one. Later.